Hi. I want to go over this series that I gave you in class quickly to see which ones are convergent, which ones are divergent. I'll try to go over some of them separately. So I'll start with the ones that we can apply the divergence sequence on. This is one of them. Let's see if I can scroll. Sorry for the quality of the tape, but I had to do. So this, as you can see, sorry about that. Okay. All right. So as you can see, the limit of the nth term for this series is 1. So the limit of n as n approaches to infinity is 1. So this is divergent. So this series is divergent. Okay. Which one is okay? And if you calculate the limit of, I can't find my pen. Let me see if I can get it larger. Yeah, there. Okay. This one is also, limit doesn't go to 0. As n goes to infinity, the exponent goes to 0. 2 to the power of 0 being 1. This one goes to 1. This one goes to 1. So this is divergent. Okay. So this is divergent. And here's another one. We can eliminate this quickly. This one is divergent. The limit goes to infinity. The nth term goes to infinity. Okay. Or we can compare it to 5 to the power of k over 4 to the power of k, which is a divergent series, divergent geometric series. What else? This one is also, no, that's not the obvious one. Let me check what else. Those are the three that diverge pretty quickly. Now, let's consider this guy. This one you can compare it to 1 over n, and it's divergent. This you can compare it to 1 over n, and it's divergent. And so this one is convergent. Okay, you can compare it to 1 over n squared. This is an alternating series that goes to 0. The limit of the nth term goes to 0, and you can check that the nth term is a decreasing sequence, so this is convergent. This one is actually a geometric series, -3 times -3 over 8 to the power of n, and it's a convergent geometric series. The root test tells you that this is convergent. Nth root test, so the nth root of n goes to 3/8, so this is convergent. That's a divergent series. You can apply the integral test. Okay, and it's divergent. This one, let me check. Oh, ratio test is divergent. This is divergent. You apply a ratio test. This one, this is convergent. Let's see. We can do a comparison to 1 over e to the power of k, and then the limit will go to 1. So it's convergent. This is also convergent. We can compare it to 1 over e to the power of n squared. Or we can do the ratio test. Yeah, those two we can apply the ratio test. So these two we can apply a ratio test also, I think. Number 10. Oh, okay. I can't see. This is n cubed. This one is integral test. So that's n cubed. This one is integral test. This one is ratio test. This one is conditionally convergent. It's divergent without the minus 1 to the power of n plus 1, but it's convergent with the minus 1 to the n plus 1. All right, so let me see. Let's see. I can't find my mouse piece. Can't find my mouse piece. Okay. This is alternating series. This is conditionally convergent. That's also conditionally convergent. Otherwise, it's without the minus 1 to the n. That's, you can compare it to 1 over square root of n. So it's divergent. This also, you compare it to 1 over square root of n. This is divergent. You can do a ratio test. This is convergent. You can do also do ratio test on this one, or root test. This one is convergent. Comparison test with n over 1 over n squared. Oh, this one is divergent. You can compare it to 1 over n. And the thing is, the limit of tan of 1 over n is 1. Okay, so this, I'll probably do it on a separate video on that one. Okay, this one is direct comparison to 1 over n squared plus 4n. This is convergent, so this is convergent too. Okay, absolutely convergent. Okay, this is absolutely convergent. That's a root test. Convergent. This is convergent. This one is tricky. You compare it to 1 over n to the power of 3 over 2, and it's convergent. That one is tricky. This one is direct comparison with 1 over 2n, so it's divergent. This guy is divergent. This one is convergent. If you do the root test, the limit becomes 1 over e, which is less than 1. That's a little tricky. This is the trickiest of all. I won't tell you what it is now. Let's see. This one is conditionally convergent. That's divergent because the limit doesn't go to 0. I think 15. The ratio test will give you 1/3. Ratio will give you 1/3, the limit of the ratio. So it's convergent. So what's left from this page? This guy is convergent. Notice that that's less than 1. So that's you can compare it to 1 over n squared. 27 is convergent. It's a little tricky, so I'll probably do it in class. And this one is also convergent. Direct comparison to 1 over, or pi over 2 over n square root of n, some constant, because tan inverse of n is less than pi over 2. Okay, I can't scroll down. I'm not able to scroll down. I wish I could. Let's try. Yeah, I lost my mouse piece. All right, well, that's the best I could do. All right. Okay. Number 12 is a conditionally convergent series. Let me check. This one is conditionally convergent. Okay. Uh-oh. I lost my pen. And I'm over 10 minutes mark. Let's see. I lost my pen. Okay, number 12 is conditionally convergent. 13 is a ratio test, it's convergent. Okay, there am I. Okay, this is conditionally convergent. And this one is a ratio test. This is convergent. Okay. And 25 is, I believe, divergent. You can do ratio test on it. That's convergent. You can do ratio test on that one also. This is the root test, gives you convergent. This is a little tricky, but I found out that this can compare to 1 over n and is divergent. This is a little tricky. And I think besides number 36, which I think I'll do it in class perhaps, that's pretty much it. And thank you. Goodbye.